James will now prepare this solution. Using an ordinary graduated cylinder, pour about 150 milliliters of distilled water into a 250 milliliter volumetric flask. Add the 62.4 milliliters of concentrated acid to the water in the volumetric flask in small portions at a time. Swirl the flask after each addition. Rinse the beaker well with distilled water several times and add the rinsings to the volumetric flask. Dilute to the mark with distilled water from a wash bottle or a Pasteur pipette. Stopper the flask and mix the contents well by inverting it several times. Sometimes we have to prepare a dilute solution from a more concentrated stock solution of known concentration. Let's prepare 100 milliliters of a 2 molar solution of sulfuric acid from a stock solution with a 6 molar concentration. Recall, the molar concentration or molarity of a solution is the number of moles solute in 1 liter, 1000 milliliters of solution. The solution is homogeneous, and multiplying molarity by a given volume in liters will give us the number of moles solute in that same volume. When a given volume V1 of a concentrated solution with a molarity M1 is diluted to a final volume V2, the number of moles of solute in both solutions is the same. We can show this through this equation. The difference between 100 milliliters and 33.3 milliliters, 66.7, is the approximate volume of water required for this dilution. When making this dilution, first put water in an amount less than you'll need in a volumetric flask. In this case, say 50 milliliters. Measure out 33.3 ml of 6 molar sulfuric acid. Pour this slowly, using small amounts at a time, into the volumetric flask. Swirl after each addition. Dilute to the mark with distilled water from a wash bottle. Shake well. We frequently measure the concentration of water pollutants in units of parts per million, read as ppm or milligrams per liter. Most of the chemical pollutants are harmful even at levels as low as a few milligrams per liter.